Hey, I've been playing around with the Raspberry Pi Pico over the weekend and got a pretty interesting, it's a very, very positive experience. The Raspberry Pi Pico has a burned-in ROM, or programmed in, a bank of ROM, I'm not sure how it works, which functions as a mass storage device. So your processor, your MCU, your microcontroller, that's words. Your microcontroller can, at any point, turn into a mass storage device ready to receive binary files, hex files that it will dump into memory. And if that seems like a lot of effort to go through just to make programming it more accessible, well, you're not wrong. The problem of programming microcontrollers has been that it is actually somewhat complicated. You need to know a lot of information. You need to be able to troubleshoot. It is a significant barrier to entry. Yeah, for pretty much any DIY device. That is partially why I recommend and use so often the Teensy loader, because the Teensy loader makes it so simple to do any kind of reprogramming on it. But the idea that there's different bootloaders and they're talking different languages, and you need a VR dude here, and then you need I can't even remember it. I have cheat sheets for how to program some of these microcontrollers, because some of them just behave differently. DFU programmer, what are the settings that DFU programmer needs? And you offer someone a giant string of DFU programmer space dash C AT mega 32 U4 space whatever baud rate space whatever bit start point, all that stuff. It was always very niche, kind of, and you had to figure out what it was, and you had to figure out how to put the chip into that state. But not so anymore, and that is a big deal. That's why I like the Teensy loaders, because there was a hardware button you could push, and no matter what happened, you could push that button and it would start talking to the Teensy loader. And the Teensy loader was dead simple and had a unified experience across all platforms. So now we have a perfectly generic mass storage device. It's using flash memory. I don't think that's a problem. Alright, so if you want to program the microcontroller, you hold down the boot button, boot cell button, and then you plug it in. So you give it power while you're pushing in that button, and then you release the button, and then it boots into a USB mass storage mode. Then you can drag and drop any kind of program you have for it. What happens after you drag and drop, though, is the MCU will run its own program, whatever program you loaded it with. So that becomes a little bit more, there's still some impenetrability to it, because you can't really get direct output from it, or at least not easily. You can't see what it's doing. You don't really have something that you can interact with it. You have to compile your code, load it, see what it does, diagnose what the issue is, compile new code, load it, see what it does. And and that is done away with CircuitPython and probably with MicroPython. So far, CircuitPython seems to be further along. I'm just starting with that, just messing around with that. So when you load it with the CircuitPython code, which you obviously just download directly from Adafruit's website, you hold down the boot cell mode, you plug it in, it has a mass storage device that opens up, you drag and drop that UF2 file, CircuitPython UF2 file that you downloaded straight from their website. You don't have to do anything with it. Then once you do that, it loads the code and it runs a I don't know, I said that Forth was a compiler, an IDE, and a REPL in one, and an operating system technically. And that's kind of what you're getting with CircuitPython, which is fantastic. So CircuitPython opens a serial terminal, and the serial terminal only has one thread. It opens a serial terminal and a mass storage device, not the programming mass storage device, just a slot of memory that you can load code directly onto it with. So now you have a status message that's coming out of a serial terminal, and you have another mass storage device, a separate one, that is used for loading code, but also you can access it directly. So when I plug in a CircuitPython device, two things happen. First, it opens up a mass storage device for browsing the files that are on the MCU. And it opens up a serial terminal for interacting with the running, I guess you'd call it the running thread, at least part of it, because it is doing it is actually multi-threaded. It is possible that one of them is actually just doing the mass storage and the other is running the code. But if you connect to the serial terminal for it, and this is not, don't let your eyes glaze over when I say serial terminal, because if you open the mu editor, mu-editor, if you can install that, it has a preset for the Raspberry Pi Pico with CircuitPython, and it will connect to the Pico. It'll connect to that CircuitPython session, and it'll give you basically a command line interface for. I mean, it's not a command. It's a Python interpreter REPL that is being run by the chip. So then you can copy and paste code directly into that interactive mode, the Python interactive mode. Or you can say, all right, I'm done talking to you, just run whatever the host code is, whatever code I previously loaded on it. And it'll run code.py, which appears in that mass storage device, that CircuitPython mass storage device. And if you don't like what that code is, you open it up in whatever editor you want, you grab it into a buffer, you work on it, you modify it, you save it, it saves it directly to the Pico. CircuitPy recognizes that it got a new code.py file and reloads the code and runs it immediately. And if it fails, if you put a bug in there, then your serial terminal, your session, your Python interactive mode, your Python interpreter is going to dump out error messages. And Python error messages are very nice. So it's very, very accessible. So it's, bad entry, bad code, unknown module at line 14, and then you can go back to line 14 and tweak it. But I just had this I had this moment where I was editing code in my choice of editor directly from, essentially, the microcontroller. I write back directly to the microcontroller to make it do stuff. I just hit save, and it immediately runs the code. And if it gives me weird errors that I can't quite figure out, I open up the Python interpreter, and I start typing in module names or typing in instructions one at a time until it yells at me because something's wrong. And then I troubleshoot why something is wrong. Actually, I had a weird bug where you actually load libraries, Python libraries, into the mass storage device by dropping them in the lib folder. There's a lib folder in there, and you drag and drop those Python libraries in there. It's crazy. And then if you want to try a new version of the code, you can open up your interactive mode, and in that interactive mode, instead of running soft rebooting and running the whole thing, you can test your own code loops in that interpreter. Now, it doesn't have the same namespace as the code that it's loaded with, and if you soft reboot, it'll wash out whatever changes you were testing. But that doesn't apply when you're, or that doesn't make a difference when you're copy pasting, a giant block of code in there, because you're loading it into that REPL memory space. So you're not even touching the existing file. So you can get in there, futz around with it, mess things up, and then reboot it, and you're right back to where you started. You're right back to that the code that was previously loaded. You can't screw it up. I mean, you probably could, but it's very hard to. Very, very, very impressive. I went ahead and put together one of these things. It was extremely simple. Just tons of fun. So it's USB mini master race here. It exposes the pads for D plus and D minus on the bottom of the Pico, so it's super easy to get a different connector on there. Fantastic. Really impressive stuff. I highly recommend it, obviously.